Welcome back. Again, we have pre-class to get started with, so go ahead and do these three pre-class assignments and enter your answers on Edpuzzle. For today's lesson, we're going to go ahead and cover section 3.2, and we're going to solve linear systems algebraically. The essential question, how do you solve a system of linear equations algebraically? And then hopefully by the end of this lesson, we're going to be able to solve linear systems algebraically. So there are two methods that we're going to use today. The first method is called the substitution method. So the substitution method involves basically three steps. We're going to solve one of the equations for one of its variables. Step 2, we're going to substitute the expression from step 1 into the other equation and solve for the other variable. And then in step 3, we're going to substitute the value from step 2 into the revised equation from step 1 and solve. So let's go ahead and do the next example using the substitution method. So here we go. We have the system 5x minus 2y equals negative 10 and 2x minus 4y equals 12. So again, remember, I like to go ahead and I like to number my equations. That's my first equation and there's my second equation. So in the substitution method, the first step that we're going to follow is to solve for a variable. So it looks like what's going to be the easiest thing for me to do? And it looks like I'm going to use equation number 2. So I'm going to solve equation number 2 for, and I'm going to solve for x, because that's going to give me no fractions. Okay. So writing equation number 2, I have 2x minus 4y equals 12. I'm going to add 4y to both sides, because remember I'm solving for x now. And I have 2x equals 4y plus 12. I'm going to divide everything by 2, and I'm going to get x equals 2y plus 6. Okay, so that's step 1. Now, step 2 of this process says to substitute, that's the substitution method, what I just solved, so we're going to substitute x equals 2y plus 6 into my other equation. So we're going to substitute that into equation number 1. So equation number 1 is 5 times x, but hey, I just solved for x, and that was 2y plus 6. Notice when I substitute, I always put that in parentheses, minus 2y equals negative 10. So to solve it, I'm going to need to first distribute. So we're going to distribute the 5, and I have 10y plus 30 minus 2y equals negative 10. And then combining like terms, it looks like I have 8y plus 30 equals negative 10. If I subtract 30 from both sides, I'm going to have 8y equals negative 40. And then if I divide both sides by 8, I'm going to have y equals negative 5. And that's one answer. Now I need to solve for x. And in the substitution method, it says now I'm going to take that and substitute it into what I solved for x in my first round. So we have x equals 2 times negative 5 plus 6. So we have x equals negative 10 plus 6. And we have x equals negative 4. And there's your other value. And then remember that the solution to a system is an intersection point, so I like to write this as the intersection negative 4, negative 5. And there is my final answer. Now, sometimes it's not easy to solve an equation for a variable. You get fractions, and this is a lot more work. So another method is what's called the elimination method, and sometimes this is easier to use. And again, we have a 3-step process. So step 1, you're going to multiply one or possibly both equations by a constant to obtain coefficients that differ only by the sign for one of the variables. So basically in step 1, you're going to choose, are you going to get rid of x or are you going to get rid of y? Whichever one is going to be easier for you to eliminate. So you're going to find out which multiple is going to be easier. Then in step 2, you're going to add the two equations together so that you cancel or eliminate one of those variables so that you only have one variable remaining. Thus, you can solve for that remaining variable. And then after that, in step 3, you now can substitute that back in to your equation, and you can solve for the remaining variable. So let's see how that looks with example 2. So here's the equation, or system, 8x plus 2y equals 4, and 2x plus 3y equals 13. So again, you notice I like to number my equations 1 and 2. First step is, which variable do I want to eliminate, the x's or the y's? I am going to pick the x's only because I notice the x's are opposite signs, so that helps me already. When I add them, they're going to cancel. And if you notice, I can easily multiply the 2 by a constant and get 8. With the y's, I would have to multiply both equations by a number so that I get the same number. So let's go ahead and think about what number I can multiply to get rid of my x's. And it looks like I can multiply by 4. So rewriting the system, the first equation stays identical. We have 8x plus 2y equals 4. The second equation now becomes negative 8x, notice I'm distributing the 4, plus 12y equals 4 times 13, which is 52. Then you add the equations. So you're going to add like terms. Notice 8x minus 8x, those go to 0. That eliminates, that's why we did that. And the y's become 14y equals 56. Divide both sides by 14, and you have y equals 4. All right, now that we've done that, the next step is you substitute the y equals 4 into either equations 1 or equation 2. So I'm just going to pick equation 1 because it doesn't matter. So we have 8x plus 2 times y, which is 4, which equals 4. Solving for x, so we have 8x plus 8 equals 4. I subtract 8 from both sides, so I have 8x equals negative 4, and I divide by 8. So I have x equals negative 1/2. There we go. We have our y value, we have our x value, and then remember, I like to write this as the intersection point, so negative 1/2 comma 4. And there is your answer. All right, so let's try some guided practice problems to see if you understand this. So go ahead and try them and enter your answers on Edpuzzle. Okay, so let's try an example number 3. So we have, at a pizza restaurant, it costs $4 to make a small pizza that sells for $12, and it costs $6 to make a large pizza that sells for $15. In 1 week, the restaurant spent a total of $1,100 making pizzas, and it sold them all for $2,910. So we have small pizzas. I'm going to call them X. We have large pizzas. I'm going to call them Y. All right, and we have 2 separate equations. We have the equation for the cost, and we have the equation for the sold. So for the cost, it looks like it costs $4 per small pizza plus $6 per large, and that's going to give me a total of $1,100. When I sell it, I sell small pizzas for $12, I sell large pizzas for $15, and I'm going to make $2,910. All right, now that I have my system, I need to eliminate a variable, and it looks like I can easily get rid of my x's by multiplying the top equation, or the first equation, by negative 3. And then when I do that, I get negative 12x minus 18y, and that's going to equal negative 3,300. When I add these together, my x's cancel, and I'm left with negative 3y equals negative 390. Dividing both sides by negative 3, and you get y equals 130. Now we substitute that into one of the original equations, so how about the first one? So we have 4x plus 6 times 130, and that's going to equal 1,100. So 4x is going to equal 320. So x is going to equal 80. So therefore, how many small pizzas did we sell? We sold 80 small pizzas. So, how do you know what to do? Well, in general, the substitution method is convenient when you can easily solve an equation. And that usually works when one of the coefficients is 1 or -1, as in example 1. If neither variable has a coefficient of 1 or -1, it's usually easier to use the elimination method. So again, you have your choice. Just do whatever is easier for you. So let's look at example 4. We have two ones we're going to do. Let's solve both of these systems. All right, so let's take a look at this first one. And it looks like if I choose to get rid of x, all I have to do is multiply the top equation by -3, and that's going to get rid of my x's. So I get -6x plus 9y, and that's going to equal -12. All right, 0, 0 equals -4. That's false, isn't it? If I get a false statement, what that means is there's no solution to this system. So what that really means is these must have been parallel lines. All right, let's try the next example here. Well, let's get rid of x's again. Why not? To get rid of x's, it looks like I can multiply the top one by 6. So I get 6x minus 6y equals 24. When I add them, I get 0. I get 0 equals 0. Ooh, that's true. If that happens, that means no matter what xy I pick, it's always going to work. So that means I have infinitely many solutions. So these lines must have been right on top of one another, or the same line. All right. So let's try to guided practice 5, 6, and 7. Go ahead and plug your answers in on Edpuzzle and see how you did. Excellent. Now let's try 8, 9, and 10. Wonderful. All right. So how do you solve a system of linear equations algebraically? And that's the end of today's lesson. So let's see you tomorrow.